Hello, welcome, and thanks for joining us today. We want to share with you the work that we've been doing in the augmented reality space at Bayer Crop Science. And so as you can kind of take a look at our objectives, we'll be talking about kind of the problems that we're solving, the difficult or the different types of AR technologies that we're testing and developing, and also the research paths and the decisions that we made along the way. So before we get started, I'd like to give you a little bit of context of the work that we do. We operate in a global agricultural marketplace. Our business sector is the discovery and advancement of seed, trait, and crop protection products. Things like row crops, seed corn, soybeans, cotton, etc., vegetables, crop protection solutions, things like insecticides, herbicides, fungicides, and other diseases. And then we're also involved with some horticulture and environmental issues. Okay, so just a word about our products. We reside in the Products and Engineering Organization, which builds enterprise IT software and technology solutions for key contributors within the R&D pipeline. We're currently developing technology solutions that integrate with data from farm equipment, satellites, field sensors, irrigation systems, drones, and others. And one thing to kind of keep in mind, we are as much a data science enterprise as we are a crop science. If you think about it, seed and trait product pipelines can take up to 6 to 8 years before the products arrive in the commercial marketplace. Okay, so just a word about our end users. Our users range from farmers and growers to trained agronomists to specialists like breeding and biotechnology and other functional researchers and scientists. Our constituents are business leaders and stakeholders, product managers and product specialists, and importantly, agile software development teams. So think a minute about our roles. As a user experience researchers, we are focused on understanding our users' problems, needs, and goals, and effectively communicating our findings to our constituents, and then objectively evaluating and testing technology designs and solutions. So you might be asking, how did we get involved with augmented reality? Well, it really started with an initial use case where we were looking at in-season data collection through mobile devices. Our mobile products group product manager was interested in building a product vision and roadmap for existing mobile data collection applications. And he wanted to know, how well are our current mobile applications working? We started off our efforts by interviewing a large sample of current mobile users. And what we found was that the data applications were providing the right level of functionality, but our end users were struggling with actually using them in the field. And so this begged an important question, why? What we found as a result of our interviews was there were some multiple root causes. So it really kind of turned out to be the interaction of the device itself. So small tap targets, small display sizes, and then deep navigation design within the mobile design. And then the environment, of course, things like moisture, glare, foreign materials, those sorts of things. And then also the task itself. So for example, people were continuously shifting their visual attention from the device display to the plants or field conditions of interest. And so collectively, the results were we had entry of incorrect data values. So a fair amount of after data collection quality checking. Also capturing data on paper for subsequent data entry, again, not leveraging the technology or not capturing the data at all, so data mortality. So in total, the costs around this: tool underutilization for sure, data mortality, and then unwarranted plot or trial destruction. Okay, so as we thought about this problem and how we wanted to go about solving it, we thought first about the key attributes of our solution. We didn't really dive into a solution per se, but what aspects of the solution do we want to solve? And right away, it was apparent that we needed a hands-free experience, right? And so this provided the freedom to input or inspect plants with both hands and to input data without using our hands or fingers. Speech to text seemed to be a key enabler, right, for data entry. So that was important, as was heads-up display. So once I was able to enter the data verbally, then I had the ability or the need to quality check that data on the fly by actually seeing a visual value appear in a heads-up screen. And then also, of course, outdoor use and wearability. Could it hold up under tough environmental conditions? A couple of other things that we were interested in by way of benefits to speech to text was actually invoking speech to text photo captures and then immediately tagging those, building in intelligence right away. And the value here is that I don't have to curate this later on. I can use this and store it with some degree of intelligence. It significantly reduces source image manipulation and curation. And then it also sets the stage for high quality machine learning and AI data points that can be used later on. Speech to text also provided the opportunity to gather QR or barcode capture. For example, allowing accurate and quick anchoring of relevant reference data. Some other things that came into play as well were things like the cost of the units themselves, and then also information security. And so kind of to that point, one of the things that we started looking at when we were looking at augmented reality solutions was that there was obviously more than one product on the market, right? On the one hand, we had a very wearable, let's say, tethered solution that relied heavily on the mobile phone itself, whereas on the other end of the continuum, we had really sort of a self-contained unit that really kind of delivered true augmented reality by way of delivery of holographic data overlays and those sorts of things. So, how should we go about actually gathering research to figure out how we want to kind of solve this problem? And so to kind of answer that question, our research path really kind of hit upon 4 nodes. As I mentioned before, we started off with in-depth user interviews, a classic UX product research methodology. From there, then we prototyped and storyboarded the concept so that we could share it clearly. And then we gained leadership and peer endorsement, right? So sharing it, testing the idea, and then finally validating the solution with interviews with people outside of our immediate population of interest. So we explore the opportunity in other settings like greenhouses, controlled environments, warehouses, and then things like equipment maintenance, pest control, and even safety settings. Because we hadn't really worked with AR before, we were starting from the ground up. And so we turned toward bare innovation funding to get some money. We started off with a fund referred to as the Catalyst Fund. And it's an external sort of lean startup innovation model, which really focused on rigorous discovery methodology, zero-based budget for early experiments, those sorts of things, and really kind of a Shark Tank pitch presentation at the end, very competitive. From there, we moved to the Hype Fund, which was an internal technology risk-focused fund. And this allowed us to procure hardware and enabled us to pursue proprietary software development. We knew that for the problems that we were solving, we probably weren't going to find anything off the shelf in the commercial market as is. The next step of our research strategy focused on business sponsorship. And two key organizations were at play here. One was referred to as Field Solutions, and they have a number of, let's say, boots on the ground data collectors. So they had a vested interest in improving the data collection efficiency and quality. The other was an organization called Biotechnology, and they brought us squarely into the greenhouse and controlled environment data collection use cases. And so what we learned from this was, number one, to secure multiple business functions because we were able to benefit these financial resources. And then finally, the final link in the research chain was to really engage products and engineering IT sponsorship. And so that is leveraging our own internal agile development teams. We had a team that was really focused on creating iOS agile software applications in the mobile space. And so we wanted to leverage their expertise and kind of hit the ground running. And so again, this was critical in securing plans to integrate with current mobile app offerings, and it helped moved us into the early stages of product integration into more of an actual launch opportunity. So it's this point now that I'd like to turn it over to my colleague, Carrie Roy, and she'll be able to take us through a much deeper dive into the decisions that we made along our two product augmented reality pathways.
All right, thanks, Mike. So now let's take a look at our use cases. So on the left is informed reality. So this is leveraging the Iris-Stick Z1 Premium for offline high volume data collection. And then the next one to it, you see augmented reality. So there we're working with the Microsoft HoloLens 2, and those are in our greenhouses or controlled environments. There we're able to leverage training content, guidance based on holograms, and both of these two technologies, these are kind of two paths that we're pursuing at this point. They both lend themselves towards building up machine learning and AI capabilities because they can both capture images, tagged associations with those images that will help us down the line. Okay, so in terms of our informed reality solution, we have a small display screen in the top of that Iris-Stick device, and that's mirroring what's on your mobile device. And we're also using the camera capabilities, so those enable us to capture barcodes and QR scans. And then the noise canceling microphones are really key for us. We have a lot of loud equipment running, we have fans in our greenhouses, so the noise canceling features that really enable that verbal data entry and hands-free experience is really critical for our work. So in order to begin testing this concept, we had to enable a flexible workflow. So you see on the top there, the ability to do a QR scan. Out in the field, we don't have those. So we wanted to enable verbal IDs. And in order to do that, we used a hard-coded list for our kind of unusual agricultural terms. So, phrases like blunt ear rot don't register correctly unless they're in one of those hard-coded lists. So in the realm of kind of HCI, our speech interface is very simple and avoids a lot of the interesting challenges in that field. And I think this hard-coded list is an elegant option for individuals who've been trained in the industry standard words and phrases. And so, for example, you say guinea grass, and by that registering, you avoid our traditional navigation, which would involve drop-down menus, search under weeds for guinea grass or search under disease or insects categories and more. And I think that's a real advantage with the workflow that we're pursuing here. Okay, so that is then followed by a value, and that could be a count or a rating. And that's our short loop. We also have the option of adding a photo along with a photo tag, and that's the long loop. And I'll show you examples of those use cases here. So Ed is capturing a rating for these weeds to kind of assess how well they're controlled. And what you're seeing in the top right corner is a simulation of what he's seeing. So QR scan, followed by value, on to the next plant. He's not having to write this on paper or tap it into a laptop, so we can just move through the plants really quickly. Okay, now I'm going to show you a scouting workflow. So this is the long loop. Colin's just been trained on this. He sees guinea grass, it registers.
All right, guinea grass.
Okay, counts up how many weeds he sees.
Take photo.
Now we'll take a photo and tag that photo.
Capture. Save. Guinea grass. Confirm. All right. That's good.
Okay, so those workflows are great for capturing items you may or may not see in an environment. Okay, so here's a photo of guinea grass, and we have the date, time, along with latitude and longitude. And just to show you, this is kind of a map of his pattern of scouting that he did in the field. But keep in mind, the accuracy is only as good as your phone, so it could certainly be off a few feet. Following testing with folks, we conducted surveys to find out how well this workflow worked for them. Overall recommendation score of 7.4 out of 9, so we were really happy with that. We also had some really important learnings from this first testing. One of them was the little UI. It's about a third of the size of what a mobile device could hold and you could read. So we need to be really thoughtful about that. Based on feedback, we ended up building out the record across the top. The large font in the middle tells you where you are in the workflow, and it also provides that QC check of what you just spoke. On the bottom is where we keep our commands or guidance about value entries. And so on the right is an example of the workflow we then built out for scouting. And when we came back, we did some more testing in the greenhouses. And this is just another great example where hands-free is a huge benefit. So you see this aphid infestation in the greenhouse. Traditionally, you would have bug guts smeared on the side of your paper after taking measurements. And then you would take that back to your office, enter those numbers on your computer. So our process is really much more efficient. And there's some other values to it as well. So Kim talks about the safety value of this, just not having to carry so much around. This is also important in terms of providing an additional safety option now. So with COVID, we want to reduce situations where two people are working closely together. Traditionally, ear height, which Kim is taking here, is done with one person measuring and saying the value allowed to the person next to them. So with our Accelerate workflow and hardware, we can now turn that two-person job into a one-person job, which makes it much safer in this era of COVID. Okay, another round of survey results and with improvements there. And then we also enabled a QR zoom and a photo zoom so people weren't leaning over. Even better scores there with an 8.5 overall recommendation. Okay, now we're going to move into our augmented reality use case using the Microsoft HoloLens 2. This is a really exciting technology when we can leverage Wi-Fi and large amounts of data. Okay, this allows us to put notes over plants about not discarding the tassel. With gestures, we can pull up menus. And it's also really valuable to be able to access training videos in a Wi-Fi environment. So that's also a really helpful tool for people who might be new to the role. So I'm going to talk a little bit about the specific use case, which is replacing the popper. All right, so this is the popper machine. It's popping up plants to advance, and that's based on tissue sampling. We're looking to replace this machine with holographic overlays of which plants to advance. So now, instead of having to transport these plants to the popper room and back again, we can now just have a worker look down at a tray, see which plants to advance, and then we're tracking the ID of that plant to its location in the advancement tray. We can also look at a sickly plant and say, nope, I'm going to discard that one. That's another real value with the workflow that we're looking at enabling through the use of HoloLens 2. Okay. Skipping to the end of this process, there we've got 17 of 17. Okay. So in summary, when we look to the strengths of augmented reality, we like to think about 3 different categories. First is industry fit. For us, we're really looking to drive the quantity and quality of the data we're collecting around crops. And the second thing to consider is the technology fit. We're working in really extreme environments where we have heat, humidity, it's really bright, so the screens need to be bright enough, and then noise canceling is another critical feature for us. And then finally, the augmentation of your environment through information and data, really leveraging what AR is strong at. And we find that by thinking about use cases that really sit at the intersection of these 3 categories, we've been able to find the most value for our business and for our workers. So I'd like to thank you. Please feel free to reach out to us with any questions. And we'd be happy to take questions at this time.